Hi. Hi, everyone. Hope everyone is doing great, and I hope you had a great weekend with full of learning. And as you all know, today we have Professor Julian with us, and words do very little justice for the kind of impact he has been creating among the learners in the community and also outside the community. And along with other coaches, he has been very proactive in reaching out to the learners and addressing their issues and other stuff. Let me quickly give a brief formal introduction about Professor Julian. I think, many of you may not be aware of him. So he's currently a graduate professor of cryptography, applied cryptography, and data science. And also, he's an undergraduate teacher for subjects like discrete mathematics, programming logic, operating systems, computer security, fundamentals of data science, and others. And not just that, he's also the director of research group and algorithmia and competitive programming. That's where, my background lied in the past. I was associated with a competitive programming platform too, and through which, he has empowered and mentored various students to participate in several national and international programming competitions. And he's currently leading 4 research groups as well, and with whom he's applying different learning deep learning techniques in digital forensics. And that's some introduction about Professor Julian. And Professor, it's all yours now. Please go ahead. Yeah, you can start sharing your screen, and it's all yours.
Sure. Hello, everyone. Good morning, good afternoon, good evening. Thank you for the introduction. Thank you for having me, Chanukya and DPhi team.
Thanks.
I'm just
It's
going
our
to
pleasure.
share.
Yeah.
Thank you, my screen. So can you please tell me if you are watching my screen?
Yes, we are able to see your screen. Yeah, it's perfect.
Yeah, perfect.
Yeah.
So let me do this. So today's session, we're going to talk about data science for cybersecurity analysis. We are basically going to mix cybersecurity and data science aspects to see if we have got some insights, some additional insights in cybersecurity using data science practices. So thanks for introducing me. Basically, I'm, as you said, graduate and undergraduate professor at the Faculty of Computer Science Engineering in Pontifical Bolivarian University. And you can find more information in this LinkedIn and ResearchGate profiles. So let us start with this session. We are going to delve a little bit in an introduction and fundamentals to see what cybersecurity is, what are the challenges, what does it mean to have IoT devices connected, what are cyber attack practices, and then we are going to see a little bit about the key verbs and the key concepts in cybersecurity. Then we are going to delve more in the applications of data science for cybersecurity. And then we are gonna see this use case. This is a real data set that I'm gonna use, and you're gonna be able to see this use case for applications on data science in cybersecurity context. And finally, we are gonna have a couple of conclusions and a future work. So I would like to hear maybe one opinion. I just wanna be very interactive in this session. So if you can give me just one opinion of what do you think cybersecurity is, it would be fine. So maybe I'm just gonna leave you a couple of seconds, and maybe you can say to me what cybersecurity is. So any one of you? All right. So I am just gonna tell you what are the challenges of cybersecurity. So those that you see in this slide are the challenges for cybersecurity. As you are watching here, you are not seeing any technical aspects of cybersecurity. I'm just showing some devices. So currently we are talking about smart everywhere. So we have smart washers, smart toilets, smart bicycles, smart bulbs, smart showers, blenders, smartphones. So everything is smart nowadays. And this is because these devices are a sort of intelligent devices that are connected to a network. So can you imagine what can we do with these devices connected to a network? So we have to create an environment of cybersecurity so that these devices are secure. This is one of the main challenges in cybersecurity. these smart devices. And this is what we call IoT, Internet of Things. Another challenge is the cybersecurity attacks. So product of these joined devices in the internet, the attackers are able to perform cybersecurity attacks, such as phishing, for example, farming, phishing, smishing, sexting, or even social engineering. So these are all plenty of cybersecurity attacks that an attacker can perform to our devices that are now connected to the internet. So imagine if in your house you have maybe a smartphone and the smart washer connected to the internet, what the attacker can do with this. So this is a real challenge for us. But not only in our home, there are plenty of breaches and challenges in cybersecurity in other contexts, such as the industry, the institutions, university and schools, the public and political aspects, the financial, migration, hiring. In all the context, we are talking about cybersecurity because we are talking about IoT in every context. We are talking about cyber attacks in every context. So this aspect of cybersecurity needs to be calculated in every of the contexts that we are talking here. Other challenges. We are talking about smart as our devices, but we are also talking about cyber. So we have cybersecurity, cybercrime, cyber attack, cyber. And this is because we have a cyberspace and everything is connected to internet. So we have to be very careful with our policies of cybersecurity in this aspect. Second challenge, the big data. We know that these devices are producing a lot of data per second. So we need big data techniques to process this data. We need machine learning, artificial intelligence, deep learning, reinforcement learning, business intelligence, and whatever the concept is. And I think most of you know about these concepts. But as we, as cybersecurity specialists, know how to implement these techniques, the attackers also know how to implement these techniques. So this can be from our side or from theirs. So we have to be very careful on how to implement these things because the attackers can implement these things too. The third aspect is going to be quantum computing. So we currently have a classical computing, and nowadays we are waiting for quantum computing. So this is a real challenge for cryptography because you are going to be able to perform operations that with classical computing you're able to perform in 1,000 years. You are going to be able to perform these quantum computing instructions maybe in 100 seconds. So this is a real challenge for cryptography and also for cybersecurity. Other types of challenges, these protocols that you see in the fourth bullet, we know about Wi-Fi and we know that the devices are connected to Wi-Fi, right? But there are plenty of protocols such as Li-Fi, Zigbee, MQTT, AMQP, and every protocol has their own instructions and their own way to transmit the information. So we have to be aware on what the protocol is doing and how to protect ourselves against the attacks that may occur on these protocols. And finally, we have cloud computing. We have the generalization of everything is smart nowadays that is called IoT, Internet of Things. We now have IIoT, which is Internet of Things to industry. And we are now talking about Internet of Everything. So everything is going to be connected to internet. So can you imagine how difficult it's going to be to perform cybersecurity practices to everything that is connected to the network? Maybe in your house you have barely 10 to 15 devices connected to the internet. So imagine how it's going to be this worldwide. So it's going to be very difficult to process this data and to implement cybersecurity practices. And this is where we as data scientists come. So we have to process this data to understand what the patterns are and how to produce policies for cybersecurity and for these devices that are connected to the internet nowadays. Here are a couple of key verbs in cybersecurity. So when we talk about data, we are talking about protection. So the data needs to be protected. When we add some analysis, interpretation, and discussion of data, we end up with information, and the information needs to be assured. And when we add a couple of lines of context to this information, we end up with knowledge. And this knowledge, as it is an abstract concept, it needs to be managed. So three key verbs in cybersecurity: protect, assure, and manage. And that is why you have maybe heard about data protection policies and about information assurance policies. So these are three key verbs in cybersecurity. How is this pipeline coming? So tell me.
Yeah, I'm really sorry. Just to is it I think like the voice is slightly low pitched. Maybe it is away from mic or something.
I guess I'm just gonna try to do this.
Yeah.
Are you currently hearing me well?
Yeah, I think it's slightly better maybe. Yeah. Cool.
All
Like, and
right.
I think we can go ahead. Yeah.
Yeah,
Perfect.
thank you, Shanika.
Yeah.
Okay, so this pipeline comes from data. So we start acquiring data and protecting data. And then when we add some analysis, interpretation, and discussion, we end up with information. Then when we add some context, we have knowledge. And then when we start connecting those dots of knowledge, we have some insight. When we connect all those insights together to perform further policies, we have the wisdom. So this is called the DIKW pyramid, and it's basically a pipeline from data, acquiring data, to gain some knowledge and to gain some wisdom. So this is key in data science, and this is also key in cybersecurity. For collecting data, maybe with big data or machine learning techniques, to have the wisdom. So this is really key for us as data scientists and as cybersecurity specialists. But I am talking about data, information, knowledge, and all of this, cyber, smart. But what makes really the information so desirable to be accessed without permissions, to be kidnapped or deleted? It is because the information is critical, it is sensitive, and it is valuable. And that means that information is a synonym of competitiveness, of advantage, and of power. So if your company has information that is important, product of any analysis, interpretation, and discussion of data, it means your company might be competitive in this field. So the attacker wants to be competitive too. So this is key for us as cybersecurity specialists, and that is why we call this the key verb of assurance. So we assure the information so that we are competitive and the attacker cannot be competitive too. Of course, the attacker just want to kidnap, delete information for other purposes, but we are talking here about competitiveness in the industry. So this is key in cybersecurity, and we need to implement data science practices in order to see what is going on, in order to see what the patterns of the attacks are, so that we can protect the data and assure the information. So this is the connection between data science and cybersecurity. Some important principles in cybersecurity are the ones that are here in this slide. This is called the CIA Triad. We have first the confidentiality. The data and the information needs to be confidential so that we can ensure that nobody accesses this information unauthorized. The information needs to be integer. So we talk about integrity so that the attacker is not able to hijack or modify the information. And we talk about availability so that the information is always available for everyone. Product of these three properties, we have traceability, which is keep trace of the information and the modifications made on the information. And we have authenticity and authentication, authorization, just for traceability also purposes, so that we can maintain some trace of the modifications of the data. So these are the principles for us in cybersecurity, and we have to take these principles into account when implementing data science techniques. So I have been talking about cybersecurity. Now let's see a little bit more about the cybersecurity attack. This is called just a cyber attack. The cyber attack goes as follows. The first step of a cyber attack is the reconnaissance. So in reconnaissance, we are just trying to recognize what the target machine is going to be. So it is just a step of gathering evidence of the target. So imagine I am an attacker. I'm not going to be an attacker just for this example. I am an attacker and I just want to break into your house. So the first thing I need to do is to identify that I want to attack your house and that I want to break in your house. This is the recognition step, just recognizing that my target is going to be your house. The second step is identifying if your house has have any vulnerabilities. So perhaps there's a window open, or there's a door open, or the seal is broken. Any vulnerabilities that I can see in your house, I can scan them, and I can make an effort for penetrating and for breaking in your house through these vulnerabilities. So this second step is the scanning process for identification of vulnerabilities of your house. The third step, when I have identified these vulnerabilities, so I have seen that your door is open, so I can gain some access to your house. So I break in your house. This is the third step, just gaining the access to your house. The fourth step is going to be keeping the access. So I just want to keep access because I want to steal the jewelry in your house. So I start stealing the jewelry in your house. This is the fourth step, and is the keeping access. And the fifth step is covering the tracks. So once I have steal all the jewelry in your house, I just want to cover all my fingerprints so that the cybersecurity specialists are not able to follow me. So this is an analogy for the cybersecurity attack process. And this is a pipeline that every attacker follows, from reconnaissance to covering the tracks. This is very important for us because here we can see a pattern, and the cyber attacker follows a pattern. So we as data scientists need to unveil these patterns so that these fingerprints that the attacker was trying to cover, we can unveil them. And this is key for us as data scientists to apply this exact pipeline as ethical hackers to cybersecurity attacks and find patterns. Some key concepts to understand the use case that I am going to present. We have been talking about cyber attack. The attack is just an attempt to expose, alter, destroy, steal, gain, unauthorized access to an asset. And it's called cyber because we are performing an attack in the cyberspace. So we are talking about cyber attack. The logical ports can be seen as the endpoints. So imagine that your house is the asset. These logical ports are going to be all the doors that communicate you in the inside to the outside. So the logical ports in a computer are basically the doors in the computer that are able to communicate your information from the inside to the outside. These logical ports are labeled from 0 to 65,535. And they are called logical because they are not physical. They are just digital transformation of this door that is physical. We have the source port and the destination port because in a communication, we always have 2 points, the source and the destination. And because we have 2 points, those points need to communicate. And the form of communications is called a protocol. So this protocol is just a set of rules that is allowing us to communicate, to transmit the information from one point to another point. And these points are also able to be labeled. So as your name is Chanukya and my name is Julian, and I'm communicating with you, these machines are also labeled with names, and the names are called IP addresses. So we have IPv4 addresses and IPv6 addresses. The 4 and the 6 is just the version of the IP address. And with these 4 concepts, we are able to communicate from one computer to another. How can we apply data science practices to cybersecurity? So most of the data science practices applied to cybersecurity consider basic techniques such as EDA, regression, classification, supervised and supervised learning. Maybe machine learning and deep learning are also techniques that are used to cybersecurity. So as you can see, data science might be transversal to any practice here in cybersecurity. We talk about some practices in here in this slide. although there are plenty of examples of other practices. Maybe event correlation is one of the most interesting applications of data science in cybersecurity. Here, we want to relate multiple events to the same pattern. We have risk assessment. We have digital forensics, which is one of my specialties. We have spam filtering, which was one of the examples that was shown in the previous session, in yesterday's session, if you remember. There is implementations of data science in phishing emails for detecting the phishing practices of attackers, and also for monitoring the network from the communication with from one point to another. So there are plenty of examples of implementations of data science to cybersecurity. And this is very important for us because we as data scientists, we are able to implement these practices in any context, and cybersecurity is one of them. So now that we have seen the basics of cybersecurity, we are able to perform this use case. So I guess you guys have the notebook opened. So you can follow this link. In this link, you're going to find the notebook and the data set. I guess you have downloaded before. I'm just going to present to you the case. So let me know if there are further questions before I can present the use case, Chanakya.
No, there are no questions as such. So there is one question: at what point of those 5 stages is it relatively easier or significant to identify an intrusion? But I think this we will be covering in next few minutes, right? Probably like once we do that.
Yes,
Yeah,
it will be.
perfect.
Okay.
Yeah. And I think we have plenty of answers for your question, but that's fine. We should
great.
go ahead. Yeah.
Yeah, okay, thank you for your answers. Maybe we can review them at the end. Yeah, sure. So we are gonna be reviewing here some cybersecurity attacks and applying data science practices to unveil these patterns of the attacks. So this notebook is called Exploring Cybersecurity Attacks for that reason. So imagine you are just a cybersecurity expert of the Central Statistics Office in the Ministry of Statistics program implementation. And you have the following problem statement. So you want to know what are the most common cybersecurity attacks, the most accessed logical ports, and the visible patterns of these attacks. So in data science, you need a problem statement always. So implementing techniques in data science needs to have a reason, and this reason is the problem statement. So you always state a question so that you can answer that question with further analysis in data science. So this is our question, and we are going to try to solve this question, to answer this question. Probably this is very familiar to you, the packages that we are going to use. We have pandas, Seaborn, matplotlib. This is IP addresses is just for formalizing the IP address in the data set. We have NumPy, we have SciPy, which I guess we are going to be describing some SciPy methods in here, so don't worry about this package. And we have the missing no library. We are going to see further implementation with this library, so don't worry. Our data set is composed with the following attributes that are in here. So we have the time, the attack category, the subcategory, the protocol, the source and destination's IP addresses, the source and destination ports, the attack name, and the attack reference. These are the columns, the series in our data set. So we are going to analyze this data that is registered in these 10 columns. What are the attacks? We are going to analyze 9 cybersecurity attacks. The first attack is reconnaissance. This is just very straightforward. Is the first step of our pipeline of cybersecurity attack is this one, reconnaissance. We have diffusers, so don't worry if these are very deep concepts. This is just cybersecurity attacks that an attacker can perform to a computer. We have the analysis, the backdoor, the exploit, a generic attack, the shellcode, worm, and the denial of services. These are just cybersecurity attacks. There are different cybersecurity attacks, and they are performed differently. And we want to unveil the patterns of these cybersecurity attacks. So that is going to be the key in this case, unveil the patterns. So the first thing we have to do is just read the CSV. You can find the CSV in the GitHub link, cybersecurity-attacks.csv. Just perform some functions to see what is the data look like. So we have here the properties, the columns of the data. And I just want to be focused on these three columns here at first. So you can see there is a column that is just a dot, and there is a column that is stating the time, and the time is split between a very long integer, a hyphen, and a very long integer. So this is going to be the focus for us in these first procedures. So I jump into the data wrangling process. So when you perform data science practices, you need to perform a data wrangling process, which is the data preparation process. So we have seen in just yesterday's session a pre-processing stage. So this seems to be the same pre-processing stage that is called data wrangling in general. In this data wrangling step, we have data structuring, data cleaning, and data enriching. The first step for us is structuring our data. How do we structure our data? We are gonna split at first the column that is called time. So we have been seeing before that the time has two parts, one integer, a hyphen, and another integer. So we are interested on splitting this column into two columns. So we are gonna do this accessing the string parameter and the splitting function with the hyphen. This expand through is going to expand both parts in two separate columns. So as you can see in here, we now have our currently time column and two more columns in here. So the start time is going to be the first integer and the last time is going to be the second integer. And we have just split this column with the hyphen. So this is going to help you to know what the start time and the end time of the attack was. This is just the structuring procedure. You can see there is a dot column. So this dot column is very particular. If you list the unique values in the column, you see there's one dot. So this is very special. Maybe in the acquisition process, this column was added. So this doesn't represent any information for us. It is just a dot column. So we need to drop that dot column. And we drop to the time because we have split this time into two. So this is just a dropping procedure. And we end up with this data set without a dotted column and with the start time and the last time split into two columns. Then we have the cleaning process. So we have structured out our data set. Now we have to clean our data set. So the cleaning process involves how to handle missing values and how to handle other types of irregularities. So we are going to first list our missing values. You have seen before that the missing values can be listed with the isNull function and with the sum function so that we have the amount of missing values on each series. I'm just dividing this by the total observations and multiply by 100 because I want this to be in percentage. So we have the attack reference with 29% of missing values and the attack subcategory with 2% of missing values. So how can we see this visually? We can use the missing null library. So as you can see here in these two plots, in the first plot, we just have the distribution of the missing values. So you can see here in this attack subcategory column that there are just a few missing values. And how do we know there are few missing values? Because they are just 2% of missing values. And these 29% of missing values are in here in this column. So we can see that there are plenty of blank spaces denoting the missing values. This view can be visualized in the other bar plot, which is on the right. We can see the bars are representing the total amount of non-missing values. And this bar is perhaps reflecting the 29% of missing values in this space. So these are two tools for visualizing missing values. They are just the same as denoting this percentage in here. So this is mathematics and this is visually perceptible. So any of those are correct. Now that we have been seeing the missing values, we need to understand why a missing value is happening. So a missing value can be happening completely at random, or not at random. And we are going to see this in below procedures. So depending on why is that missing value missing, we are going to give that a treatment. So I'm stating here 4 treatments. We have seen in yesterday's session, the first treatment is just ignoring the missing value. It's the basic treatment. So I know there's a missing value, but I just want to ignore that missing value, because in my analysis, is not gonna make any issue when analyzing that column. The second treatment is gonna be a replacement. So we are gonna replace the missing value. This sometimes is called as imputation, as you have seen in yesterday's session. So we are gonna impute the missing values. The third step is also imputing missing values, but with interpolation. So we are gonna identify a pattern in our data and interpolate this pattern to maybe replace that missing values. So one is just replacing missing values with some words that are indicating me nullity, and the other is replacing missing values with the interpolation of the pattern that I am currently seeing in the data. And the treatment 4 is going to be dropping the missing values. So treatment 4 is very dangerous. We shouldn't be applying treatment 4 unless we are sure that these missing values are not going to give us the insight that we want. And therefore, this is just in the 4th place. It's very dangerous to drop the missing values, and it's going to be the last option for you. So how are we going to implement these treatments to our data? We are going to implement, as you can see above, we are going to implement this treatment 2 and treatment 1 to the columns that we have seen that have missing values. So treatment 2 is going to be applied to attack subcategory, and treatment 1 is going to be applied to attack reference. So you might be wondering, why am I applying treatment 2 and treatment 1? In cybersecurity, and for this analysis, this attack reference might not be so insightful for me. So I just want to leave this attack reference as missing. And the attack subcategory perhaps is going to be giving some insight to me. So I am just going to fill these missing values with a string that states that that value is not registered. So this is a very important procedure, because if you want to subset your data frame, you might want to be able to subset your data frame with the non-registered string. So those are the treatments that we are going to apply to those columns, and we are going to see why below. So as you can see, the attack subcategory now have 0, and the attack reference keeps with 51,000. So this is just the 2% of our data. One of the key aspects here when analyzing this data and when cleaning data is analyzing duplicates. So we have been analyzing missing values, and the missing values, of course, are very context dependent. We also need to analyze duplicated values. And as you can see here, there are 6 rows that are duplicated. So we need to know what to do with this duplicated columns and with these duplicated rows. If these rows that are being duplicated represent some insight for us, we shouldn't be dropping that rows. In this case, they are just an exact copy, and it will alter my analysis. So I am dropping those rows. So we end up with 6 rows less, and with the 11 columns that we currently have. And as you can see, if I try to visualize the duplicated rows, there are not going to be duplicated rows because I have just dropped that duplicated rows. Now we need to understand that, as we stated above, the logical ports are labeled from 0 to 65K. So if we find some numbers that are outside this interval, it might be a mistake. So as you can see in here in the source port, we have 67K, which is outside the interval. And we have minus values, which are outside the intervals too. So we need to treat the strange values in our source port and destination port. So I am just here stating two masks. One masks for values below 0 and above 65K for source ports and destination ports. And here I'm just subsetting with these two masks so that you can see that they are roughly 4K rows with these strange values. What am I going to do with these strange values? I'm just going to avoid them. So I'm just subset my data frame considering not these two masks. Why am I doing this? Because this is going to affect all my analysis. If my question is analyze the logical ports and the logical ports are wrong, I'm not going to be able to answer that question. So I need to drop that rows, which is the same as doing this. All right. Now, when we analyze the protocol and the attack categories, we see that there are certain names that are spelled differently. So we have TCP as a protocol, and we have TCP capitalized. And we have UDP as a protocol and UDP in uppercase. So of course, TCP and TCP capitalized, they are just the same as UDP and UDP uppercase. So we need to regularize and to homogenize these different spellings. So how can we do this? We can just uppercase everything and trim everything so that spaces before and after the string are disappeared. You can see here that also we have backdoors and backdoor. So this happens a lot. When you have multiple spellings in plural, singular, or other verbal expressions of the same word. So for example, if you have run or you have running, this is going to be the same. As this is going to be the same interpretation for you. If there is run or running, it's going to be the same. So you have to practice a little bit on NLP techniques, which is going to be a little further and in other sessions. So this is very important for us. In general, backdoor and backdoors, the singular or the plural forms are just the same. So we just need to homogenize this with a replacement. And now you can see that there were previously 14 categories. And with this homogenization with the spelling, we have now 9 categories, which is the correct one. We have stated above that there were 9 different cybersecurity attacks, and now we have 9 different cybersecurity attacks in here. Is everything okay, or there are questions, Shanukia?
No, I think yeah, we have some questions, but they were already addressed. One thing is there is a question about nullity, and yeah, how do we go about dropping the missing values or whatever it is? I mean, like, the data pre-processing thing that you have done. Maybe if you can add throw some light over there. Yeah.
Yeah, handling missing values is always controversial. And as we stated before, it is very context dependent. So for me and for us with this data set, this attack reference wasn't important. So we just leave the missing values. But for you that perhaps are analyzing prices, house prices, perhaps these missing values represent some insightful information and needs to be interpolated. So it totally depends on the context.
And there is one more quick question. Why do what is the prominence of copy method? We are using it every time, right? So copy method.
Okay, all right. So when you use copy method, for example, if I use this copy method that I have been suggesting on Slack, this copy method creates another copy in memory of the same information so that the pointer is separated from the original value through the new value.
Got it.
Okay, so it's very important to make a copy. You are stating right. It's very important to make a copy, because if you don't make a copy of certain instructions, the value that was originally established and the new value are going to be the same. Even if you update the original one, the new one is going to be updated too, and vice versa. So you need to create a copy so that both variables are splitted in memory.
Yeah. And one last question before we take another practical break. Why don't we replace those mask value with 0 or 65535?
Yes, a very good question. I'm just gonna I'm just gonna answer that with our question. So it totally depends on our question. My question, and the question that is stated in this notebook, is regarding the most accessed logical ports and the visible pattern. So if I replace some wrong logical ports with 0 or 65K, these patterns are going to be affected. So I cannot give or add some bias to my data set by doing that. So you have to be very careful on when to interpolate and when to fill null values or missing values with other kind of values, which is our 0, -1, or other values, because that could alter the pattern that you are trying to understand. So that is very critical when dealing with missing values. In this case, we are just dropping that columns, that rows, because our question is regarding the logical ports. So if we want to analyze the logical ports, we don't need to interpolate the logical ports, because that is going to affect our pattern. Okay, so I see there are no more questions.
Yeah, we can go ahead. Yeah, thanks.
Okay, perfect. So that is the cleaning process. Now, I just want to clarify on why we apply this treatment 1 to the attack reference. The treatment was just leaving the missing values in the attack reference column. Why is that? You can see here, we are just analyzing the number of missing values in a percentage regarding the attack category and the attack reference. So this is 90% of missing values in the attack reference regarding the reconnaissance attack category. So you can see here, there's a huge difference among the first 4 and the other 5. So we can see here 90% against almost 0%. So why is that? We can analyze the CVE, which is the common vulnerabilities and exposures, which is the reference for this attack reference column. And we can see here that the fusers, analysis, shellcode, and reconnaissance are some kind of cybersecurity attacks which are not documented on CVE. And therefore, there are not enough attack reference in our dataset. You can find the dataset here in this link. I click this link. This is the common vulnerabilities and exposure dataset, which establish every vulnerabilities of your system regarding any protocol. You can download the CSV and analyze the CSV as I did. And you can see that there are not enough vulnerabilities documented for fusers, analysis, shellcode, and reconnaissance, as you are seeing here in these numbers. So if there are not enough reconnaissance documentation for CVE, of course, there are going to be a lot of missing values for that attack category. So this is the reason why there are missing values with these attack categories and in the attack reference column. So the question originally was, why do I have missing values? And that is the first question before interpolating or giving any treatment to the missing values. Just why do I have missing values? You have to ask that yourself. Why do I have missing values? And this is the answer on why do I have that missing values. So this is why I just gave the treatment 1 of leaving just the column as it is, because I'm not going to be able to replace a CVE, which is another documentation of another attack, to the reconnaissance attack. This would be a bias. So I just gonna leave this attack reference as it is with the missing values. The third step is going to be the enriching step. So we have load the cybersecurity attacks dataset. Now we are going to be loading the TCP ports dataset. This is just another dataset. And we are going to merge both data frames. So I think this is going to be new for you. This is another functionality in pandas. So you can merge multiple data frames into one with a common column. So our common column is going to be the port column, the port series. So you can see here in this data frame, we have a port. And in the previous one, we have also a port. It doesn't matter if this is written differently. We have destination port, but the sense is just the same. This is just a logical port, and this is just a logical port. So we can merge both data frames on the same column for logical ports to understand what the destination port, the service is. This is the service. This is something about cybersecurity. So every protocol is giving a service. So you have HTTP, for example, and HTTP is just a service for accessing HTTP information and data. So we are merging both data frames. So we originally had 11 columns and we now have 13 columns because these two columns were added. Okay, so now that we have made this enriching process, we have added additional data, which is not biased. We have structured our data set and we have cleaned our data set. We are able to perform this EDA, which is the exploratory data analysis. What are we gonna do here? We are gonna analyze first the cybersecurity attacks. So you can see here that we have the 9 attacks: reconnaissance, exploits, DOS, generic, shellcode, user, worms, backdoor, and analysis. We can know that there are 9 attacks because we are using the unique function, which is giving me the unique values in this column. So there are 9 attacks. Of course, our attacks are imbalanced. So we have plenty of samples of exploits and maybe 1% of worms. So since we are not going to use machine learning techniques, this is going to be fine. But if we use machine learning techniques for understanding, for trying to perform some prediction tasks to attack category, we should be handling this imbalance in our data set. The exploits represent the 39% of our data. The fusers represent our 19% of our data. And you can see the worms represent less than 0.1% of our data. So if you want to visualize this data, you can plot the data as a bar plot, and you're going to see here the exploits. You're going to see the number of fusers, and you're going to see the number of worms. If you want to do the same thing in a pie plot, you can do this. We are plotting here the top 5 attacks. We can see here the exploits is in the top 5 as generic, reconnaissance, DOS, and fusers. So these are just visualizing plots that where you can see the data more understandable. Now, we have stated that in our samples, there are a lot of cybersecurity attacks. So we want to analyze the time, the date frame where the attacks happened. So you can see here that the start time of the attacks have only 2 values. And this is because in our data set, we have cybersecurity attacks from this day and from this day. Just 2 days in our cybersecurity attack, and we are going to analyze these 2 days. What happened in the company? This is a real data set from a company, which I have cleaned a little bit for you, and I have deleted some private and sensible columns so that we can make this publicly available. And we are going to analyze these cybersecurity attacks in these 2 dates in the company. We can print here and visualize some summary statistics. So we can summarize the source ports and destination ports, and we can see they have very different means and very different standard deviations and very different 75% percentile. So this is going to be very important for us, and we are going to analyze why this mean is very different from this mean. If they're both communicating from door to door, why the doors are so different? So this is key aspect for us to understand the pattern. We can calculate the correlation in our data. So you have seen that the correlation is just a linear relationship between both variables that are indicating certain relationships, but the correlations is more than just linear relationships. We have the Pearson's correlation, which is the one that we have been calculating so far, but we have also this Pearson's correlation. So the Pearson's correlation is just the traditional correlation that we are calculating with this method. So when we call the .core function, we are calculating the Pearson's correlation. But we can calculate other types of correlations, such as the Spearman one. So this Pearson correlation is just establishing a linear relationship and is giving us a strongness of how strong or weak is the Pearson's correlation, which is a linear one. This Spearman correlation is not stating linear relationship, but is stating monotonic relationships. So monotonic relationships, I'm just going to open Paint here. So you have seen that linear relationships are just modeled as a line. Monotonic relationships are a generalization of these relationships and can be seen as nonlinear relationships, such as this one, or this one, or this one. So every increase in one variable and increase in another represents a monotonical relationship. It doesn't matter if it is linear or nonlinear. So what we are analyzing with the Spearman correlation is that monotonic relationship. And as you can see here, you can see the Pearson's correlation between the source port and destination port is just very low. So it means there is a weak linear relationship between both variables. But the Spearman correlation is pretty high. So there is a strong monotonical relationship between the source and destination ports. And this difference is key for us. We shouldn't be just considering this linear relationship because it's going to be wrong. There are plenty of nonlinear relationships that can be unveiled between these type of variables, such as the one that we are unveiling here. So this is very important for you as data scientists to identify which is the relationship between one variable and the other. It might be linear, or it might be nonlinear or monotonic. So be aware of this. Now we are just getting the dummies in here. So we are replacing those categorical variables with 1 and 0s, as you have seen before. And we are plotting this relationship, the correlation, linear relations, which is the Pearson's correlation in this heat map. So you can see here the Pearson's correlation of every variable. You can see there are no dark points since there are not strong correlations in this data set, linear correlations. But if we do the same for Spearman correlation, you're going to see some very hot dots in here, which are the destination and source ports, which have a monotonical relationship. So this is different. Analyzing the Pearson's correlation, which is linear, and analyzing the Pearson's correlation, which is monotonical. So be aware of these differences, please. Now I want to show you this Perplot. You have seen that we can plot this Perplot in order to understand what the relations between one variable and the other are. But I just want you to analyze in 10 seconds this Perplot. And I just want you to think about what the relation between the source port and destination port is. So are you able to tell me what the relation is? I don't think so. So the Perplot, of course, is going to help you to unveil some relations that are visually perceptible. But in this case, you're not going to be able to see anything. So this is just dots everywhere. So this is an example of how you are performing just a pair plot, and you need to keep analyzing those variables, because in the pair plot, you are not going to be able to see anything. So we are going to keep our analysis on these two variables to see what is happening here in these dots that are not unveiling any pattern. We are now going to analyze time. And we are going to analyze time in terms of our destination and source IP addresses and destination and source ports. So let me show you the scatter plot of the cybersecurity attacks regarding this specific machine. So I am just showing you a house. So you can see this as a house. This is a machine. This is a house. So the attacker wants to attack this specific house. So I'm just filtering this house and showing you the start time of that house. So let's see the scatter plot. You can see here that in this day there were few cybersecurity attacks, and this day is what there were just plenty of cybersecurity attacks in this particular house or this particular machine. So let's dive a little more in this scatter plot. Let's see first the first day. You're gonna see here that there are plenty of dots here down, here in the bottom, and few points here in the top. If you analyze the one that is in the right, which is this second day, you're gonna see this. As you can see, there is no pattern in our scatter plot. We just see few points here at the top and a lot of points here at the bottom of the graph. So there is no visible pattern. So as we have seen in the Perplot and in this scatter plot, there is no pattern. So if we stop here and we say there's no pattern, it would be very wrong because we are not analyzing the data completely. So let me illustrate how is analyzing the data completely. So I'm just gonna zoom in this part where there are a lot of points. And let me present you this scatter plot. So as you can see here, we are able to see a pattern. So we see a pattern of just constant lines between the time and between the destination ports. So it means that the cybersecurity attacks, which are here in different colors, are attacking specific ports. They are not at random. You might be thinking, well, that is a hypothesis, right? You're saying that is not at random, but that is your hypothesis. How can you test your hypothesis? Yes, you're right. This could be a bias. If I just plot this scatter plot and I just say this is just a pattern and I stop my analysis, that could be a bias because I am not proving my hypothesis. So what we are going to do further in this analysis is testing our hypothesis from these scatter plots. So let me show you another scatter plot, and you're going to see here another pattern. This is a scatter plot that is relating the duration of the attack and the destination port of the attack. And you can see here that most of the attacks that are attacking ports below 10,000 are the duration of the attack is almost 1 minute. And the attacks that are attacking destination ports above 10,000, the attacks just last less than 1 second or 10 seconds. And this is because in cybersecurity context, this is because the attackers just attack these ports in the area of 2,000, between 2,000 and 60,000, just testing if the port is open or closed. So imagine you're an attacker and you want to break in a house. You are just testing if the door is open or closed between 10,000 door and 60,000 door. If you want to attack a house and you know that the door is open, you're gonna last few more seconds. So that is what is happening in this scatter plot. Another very interesting plot is a violin plot. So I guess you have seen the box plot and the distribution plot. Those plots can be merged in this violin plot. So in the violin plot, you are seeing here a sort of distribution, and you're seeing here a normal bell, which is normal distribution here. So this is just the merge of the box plot and the distribution plot. So they're almost identical except for the shellcode. So this is interesting why the shellcode is so different from the others attacks. In here, I'm just going to explain this below. We are going to apply a function just to extract the hour of the attack, the exact hour in the format 000000. And we are going to make a user-defined function for general heat map plottings. So we are going to make a pivot table. What is a pivot table? In short words, it's just rearranging your data frame so that there are specific columns and specific rows. So as you can see here, I am rearranging my data frame so that in the columns we have cybersecurity attacks, and in the rows we have the hour. The value that is in here, for example, is stating that there were 3 analysis attacks at 00 hour. So this is the count function, and it's an aggregation function. So we are just aggregating our cybersecurity attacks to count how many cybersecurity attacks were in this specific hours. What is giving this to us? This data frame is very difficult to interpret, right? So what we need to do is to visualize what the data is contained in this data frame. So we can do this using the heat map. So we can see here in the heat map, there is a very interesting pattern. So let me show you the following heat map. This is just the same heat map, but with a normalization. And you can see here, there is a very interesting pattern. So let me illustrate the pattern. You can see the shellcode, which is attacking at all hours. There is no darker or lighter points in here in the shellcode, but you can see here in the DOS, there are red colors in specific hours and darker colors in others. So this means that in even hours, such as 11, 9, 7, 5, 3, etc., there were plenty of cybersecurity attacks of DOS, and on odd hours, there were not. So this is very interesting because we are modeling these cybersecurity attacks, and we are stating that at some hours there were attacks and at some hours there were not. So can you imagine how it's going to be this as you as an attacker? So imagine you are an attacker and you just want to break in a house, and you are saying, hey, I just want to break in that house at odd hours, and I just don't want to break in that house at even hours. So why is that? Why are you doing that? So this is interesting. We will have to analyze what the patterns of the company are. So if the employees in the company are resting on even hours and are working on odd hours, or vice versa, this would be just very context dependent. So this is a very interesting pattern in the company of this cybersecurity attack. This is another heat map relating the cybersecurity attack and the destination IP address. So we can see here that there were cybersecurity attacks to certain machines, such as this one, for example. We have here plenty of cybersecurity attacks only at 1 a.m. to this machine. But in this machine, we have plenty of cybersecurity attacks at all hours. So why is this happening? Why an attacker wants to break in all houses at the same time in this pattern, and why an attacker wants to break a specific house in this time? So this is a very interesting pattern in cybersecurity to be analyzed and to propose new policies for the company. So imagine this is happening in several days. You can propose a policy, an IT security policy for this company at 1 a.m., for example, to this machine. So I can imagine that at 1 a.m., perhaps this is a machine that is making some backup, and this is a DOS attack, for example, and you just want to avoid the backup as an attacker. So you might want to implement a data science and cybersecurity policy for this machine at this hour, so that you can prevent cybersecurity attacks for backup, for example. So this is very interesting to analyze. This is another graph. This is another heat map regarding the attack category and the destination IP address. It's similar to the above, but this is normalized. So we can see here that the shellcode is attacking all the IP addresses, all the machines. But for example, the backdoor is attacking specific IP addresses. So this is a key pattern for us. Why is the backdoor attacking these two machines only? And why is the shellcode attacking all the machines in the company? So we have to implement some policies for these two IP addresses in these ports for avoiding this backdoor attack, and to implement different policies for avoiding the shellcode. Now we are going to see how to test our hypothesis. So we have stated some hypotheses, as, for example, the destination and source ports are different. And we have seen in the summary statistics that the mean in the source port and destination ports are very different. So we have to test this in order to know if that difference is statistically or not statistically significant. How can we do this? Using a hypothesis testing. The hypothesis testing is just for testing our hypothesis, which is called a null hypothesis. In this case, our null hypothesis is going to be the means of the source and destination ports are equal. And we are going to perform a hypothesis testing in order to maintain this hypothesis or to reject this hypothesis. How can we do this? Using the stats model in SciPy in the t-test, which is the hypothesis test. And we are going to get a p-value. If that p-value is above certain value, we need to say that that is statistically significant, and this p-value is above certain value, we are going to say that this is not statistically significant. This alpha value is just a confidence interval for us, which is 95% generally. So as you can see here, we've got a 0, and 0 is less than 0.05, which is the 95%. So we can say this difference is statistically significant. So there is a difference between the source port and the destination port. So that means that the attacker is attacking my machine, not at random. And this is very important because the attacks are going to be not at random. We can do the same hypothesis testing for every cybersecurity attack. And we are going to see that almost all the cybersecurity attacks are not at random, but the shellcode seems to be at random. So we cannot reject the hypothesis that the means between the source port and destination port for the shellcode are the same. So this means that shellcode is attacking all my machines generally without any pattern, and all the cybersecurity attacks except for the shellcode are attacking my machine with a clear pattern of differentiation of the machines. So this is very important. We can make also a contingency table, which is basically counting events of two variables. So we are counting the attack categories in terms of the destination ports. So we have here as the columns the destination ports, as the rows the attack category. So here we are stating that there are 1,000 analysis attacks in the port 0. And we can plot this heat map. Why are we doing this? Because we want to prove that the attacks are dependent on the destination port. This will help us on identifying the patterns. So if we can prove that the attack is dependent to the destination port, or the destination port is dependent to attack, it means that the attack is not at random. And it is attacking very specific destination ports in a machine. We can do this using the chi-square test. So the chi-square test have the following hypothesis: the attack category is independent to the destination port, and it is going to return me the p-value. So this interpretation of this p-value is going to be the same as the interpretation of this p-value that is stated above. So if it is less than 0.05, we reject the hypothesis. If this is going to be greater than 0.05, we cannot reject the hypothesis. It's just going to be the same interpretation. So what we've got is 0. This 0 means that we can reject the hypothesis. The hypothesis was the attack category is independent of the destination port. So it means that the attack category is dependent of the destination port, and it is not at random at all. So it is attacking very specific destination ports, and it is not at random. So the attacker knows what he's doing, and he is attacking with specific patterns to certain destination ports in my computer. We have seen this plot before. This is the plot between the source port and destination port, which is the same in the Perplot, just few dots in my screen. But there is an interesting pattern too regarding the exploits. So the exploits are these yellow dots, the ones that are here in the top and the ones that are here in the bottom. So you can see there are few yellow dots in the middle of the graph. So this means that the exploit is attacking lower ports and upper ports. They're not attacking at the middle of the graph. So this is interesting because if we want to propose a cybersecurity policy, I might say, hey, we can implement a service in a port that is here in the middle, and we are going to be able to avoid these exploit attacks. Finally, you can see this graph. This is almost a distribution graph, but using a strip plot. So you can see here that the strip plot of the source ports is almost everywhere. Those dots are almost everywhere in all the attacks. But considering the destination ports, they are not almost everywhere. So this is stating that the reconnaissance attack only attacks ports below 5,000. The exploit attacks ports below 10,000 and 50,000. You can see here there's a clear pattern in the generic attack. So you can see here lines. So I'm just gonna use the pointer. I don't know if it's gonna work. So you can see here there are lines. I zoom in a little bit. There are very specific lines on the generic plot, as you can see. So this is a clear pattern, and the generic is attacking very specific ports. So if you want to implement a policy in your company, I would suggest you change or you mask your destination ports maybe to be in this free space so that you can avoid this type of generic attacks. And you can see the pattern is almost the same for fusers, worms, and analysis. So this is very important. This means that the attacks were not at random. And we can disaggregate that in the data, showing that into the IPv4 addresses, these are the addresses for the attackers. So this means these 4 guys were the attackers in short terms. So you can see the patterns are almost the same. So these 4 machines were attacking my 9 machines almost with the same pattern. And you can see my attack machines or the target machines have the same pattern in here. So 4 machines were attacking 9 machines with almost the same pattern. So if we want to prove this hypothesis, we should use ANOVA or other hypothesis testing tools to prove that this is the same pattern or to prove that there is a different pattern. I have used ANOVA, although it is not here, and we can see that the p-value is almost 0. So it means that besides the attack is attacking a machine with a clear pattern, the attack is attacking different machines. So the attacker knows what machine to attack with what subcategory attack. So this is very important for proposing policies, because if I know what attack is attacking me and which machine is being attacked, I know what policies to implement in my company. So this is the analysis using data science for cybersecurity. Some conclusions of the analysis. I just present this slide. We can extrapolate this analysis for other cybersecurity studies, and we can delve some interesting patterns as the one I've shown you. We are able to analyze large volumes of data, as you have seen, and propose new information security policies and countermeasures for these cybersecurity attacks. So this is just an EDA. This isn't machine learning and deep learning. This is just an analysis. And we can delve a lot of information and we can get a lot of insight from this analysis to propose new security policies and countermeasures. So these data science practices help a lot in cybersecurity context. There are other kind of studies. I'm just showing you my studies on this field, specifically on digital forensics, as Chanuki has mentioned. We have been studying these patterns using artificial intelligence, machine learning, and deep learning techniques for digital forensics. We have been using these data science techniques for steganography, for digital forensics analysis, using NLP, using static analysis. So it is clear that we can use data science for every field, but we need to understand the context of the behavior and the surroundings of this field. So we need to understand how is data science working and how to apply it to cybersecurity, for example. So this is the end of the session, but as you can see in the image, although we are getting to the end of the session, we have plenty of other fields to analyze. So this sea is open. We have all the horizon to analyze and to implement data science techniques to other fields. So you can be able to do this with the knowledge you have learned in this bootcamp and the knowledge you are going to be learning in these 2 weeks of bootcamp. So thank you very much to Chanukya, to Gunika, to Bhavani, and to the DPhi team.
Thanks, Julian. Thanks a lot. I think it was an amazing presentation. And we have few questions before we sign off. We have few questions. So basically, like, if you can go through the hypothesis testing bit again, that would be brilliant, I guess. Probably if you can give a brief introductory thing about hypothesis testing, and also, like, the learners doesn't necessarily need to be overwhelmed with all of these things. It's more statistical, so probably, like, if you can add a line or two there, so that
yeah, sure. You don't need to overwhelm with this kind of operations and techniques that we are using here. I just want you to give an insight. So if you are detecting some patterns in this graph, it is just your hypothesis. So if you see any interesting patterns in here, you would need to test your hypothesis in order to know if that is a bias from you or if that is true and the data is showing that pattern. So that is why we are using this hypothesis testing in here, just to test if our hypotheses are really true and are reflected in data or are just a bias from us in the visualization process. How is this hypothesis testing working? The hypothesis testing always works using the means of two variables. So in this case, we are evaluating if the means of the source ports and the means of the destination ports are equal or not. So if this p-value is greater than our confidence interval, we cannot reject this hypothesis that they are equal. But if the p-value is less than our 0.05 confidence interval, we are able to reject this hypothesis and maybe to state that these means effectively are different and that difference is statistically significant. So this is not a bias from us. This is just a statistically significant proofs and testings for our hypothesis.
Okay, yeah. And we have one more question. What is the difference between using hypothesis testing and using any classification technique?
Okay, well, there's a lot of difference. Hypothesis testing is just for testing my hypothesis against a mean value. So you see here that it will always be the mean of two variables. So if we are using hypothesis testing, we are just evaluating if the means are different or not. If we are using machine learning techniques, that is for modeling. So that is not only analysis, but it's also modeling some key aspects. And then we need to test if this modeling is overfitted or underfitted, and if the results are statistically significant or not. So both things are very different. This is just for analyzing hypothesis, and the other is for modeling aspects of data.
Yeah, got it. And do we always have to perform hypothesis testing for wherever we find patterns? I think we had similar kind of question on YouTube too. If we are getting patterns, do we test all of them using hypothesis testing? So it is interchangeably asked, but yeah, that's the
question. We should do that. It depends on the hypothesis. So you can see here that we are evaluating the average of two variables for hypothesis testing. And in here, we are evaluating the independence for chi-square testing. So if my hypothesis is that two variables are independent, I should be performing a chi-square test. But if my hypothesis is that the means of two variables are the same, I should be stating a hypothesis testing. But always, as I am stating hypothesis, I should be testing the hypothesis because it would be a bias if not.
Okay. And when do we use a t-test and z-test? Again, like, we are going slightly statistics here, but yeah, that's probably like, we can pick this question. And for others, don't get overwhelmed. It's fine. I mean, like, we'll get to learn these things soon. Yeah.
Yeah. Okay. Well, there are plenty of statistical tests. There's hypothesis testing, chi-square testing, ANOVA, and other type of tests. So it totally depends on the hypothesis and on what you are going to state. So generally, don't get overwhelmed of hypothesis testing. It's just a tool for testing if you're biased or if the data is really showing that pattern.
Yeah. Yeah, great. And we have one more question. So basically, as a working cybersecurity professional, how data science could be useful in my career path? I think this should be very easy to answer, but yeah, you go ahead and.
Yeah, okay. Well, I have shown an example of using data science in cybersecurity. It was just an EDA, which is just an analysis. I have stated here some additional examples using machine learning techniques. So you can see here that the steganography and the steg analysis is a current word because I'm using data science for digital forensic analysis. You can use data science for cryptography, steganography, digital image processing, whatever you want. The important thing is to get known about the context, about the behavior, and about the environment of the context. So if you know the context, it's going to be easier for you as data scientists to apply certain techniques to the data. If you don't know the context, you would need to make a lot of questions and then to prove that questions, and that would be easy. So first, you need to know about the context, about cybersecurity context, about NLP context, about whatever the context is. And then you will able to apply these data science techniques to that context. And you will understand what the results are. Because there will always be numerical results. And you need to understand what the accuracy is, what the hypothesis testing is giving you, what the p-value is. So in here, the thing is understanding the context first and then applying data science techniques.
Yeah, got it. Thanks. And any message that you want to share with all our learners, probably like, your data science journey, or any tips or anything that you want to share with them before we sign off?
No, you are doing just amazingly. I'm just amazed about the questions and about the answers. Just keep moving forward. Try to apply these data science techniques to a project so that you are able to build your portfolio, so that you're able to know other fields, not only data science, and that would be great for you.
Yeah, true. I totally agree. The learners are doing just an amazing job, and I totally second that. And thanks a lot, Julian, for the awesome session. And thanks to Gunika, Manish, and Ravi at the other end who are moderating the session on YouTube. Thank you, and thanks to all the awesome learners. Thank you, and take care. Bye.